Hello everyone. I'm Poonam Sharma, your science teacher. Welcome you all to another session of Is Matter Around Us Pure chapter. Children, in previous sessions, I have explained this Matter Around Us Pure entire chapter to you. And if you want to see those videos, they are on YouTube. You can go through and revise this chapter. So we have done separation techniques in this chapter, solution, colloidal solution, then true solution, suspension, and different type of these solutions we have discussed so far. Now in today's session, I'll discuss very important question answers from this chapter. Although I have discussed few questions when I was explaining this chapter, so now in today's I'll discuss more important questions according to exam point of view. So now let's begin our class with the discussion of question answers and what type of questions can be asked in exam and how you can represent your answer so that you'll get full marks. Now question number 1. How can you change a saturated solution to an unsaturated solution without adding any more solvent to it? If you remember, when I was discussing about saturated and unsaturated solution, I told you we can convert saturated solution into unsaturated one. And two conditions are there, either by adding solvent or by increasing temperature. So in this question, one condition is already mentioned, that without adding any more solvent to it. It means we are not using this condition. So what is the other condition for this? And the second one is by heating the saturated solution. If we heat saturated solution, the particles starts gaining heat energy, kinetic energy, and they start creating more space. As a result, we can add more solute into it and it becomes unsaturated solution. So in this way, we can convert a saturated solution into unsaturated. Now second question is, two liquids A and B are miscible with each other. It means they can mix with each other at room temperature. Which separation technique will you apply to separate the mixture of A and B if the difference in their boiling point is 22 degrees Celsius or Kelvin? Now here two miscible liquids are there. Miscible liquids are those which can mix with each other. We cannot see their boundaries when we mix them. And how can we separate those miscible liquids? And the answer is fractional distillation. Two methods we use, simple distillation and fractional distillation. Simple distillation we use in those cases if boiling point is more than 20, the difference in the boiling point is more than 25. But here the difference is below 22 or 25, it's 22, so we'll use fractional distillation. And the liquid which has less boiling point, it evaporates at a faster rate and it evaporates first, then leaving the next one. So in this type of this mixture, we use fractional distillation. Now, next question is, although it's an NCERT question, seawater can be classified as homogeneous as well as heterogeneous mixture. Comment. We are saying homogeneous mixture are those in which we cannot see the boundaries of the components present in them. And heterogeneous mixtures are those in which we can see the boundaries. But here we are saying seawater is both. See, as we know, seawater is a mixture of salts and water which cannot be separated by any other method except evaporation. So we can separate salt from water by evaporation process, or further we use crystallization method to get the purest form of salt. Therefore, it is a homogeneous mixture. But it also contains mud, decayed plants and other salts. So it is a heterogeneous mixture. So apart from this sodium chloride, it contains other substances also. That's why we call it a heterogeneous mixture. So I hope this question is clear to everyone. And the next question is, why is it not possible to distinguish particles of a solute from the solvent in solution? See, if we are talking about true solution is that kind of solution in which the size of particles are very small and it is a homogeneous mixture in nature. Now, a true solution is a homogeneous. So, solute and solvent particles, the size of solute and solvent particles are very small. So, we cannot distinguish even under a microscope. We cannot see with the naked eye also, but if we take a help of microscope, then also will not be able to see it because of the size of the particles. They are quite extremely small. But this is not in the case of colloidal and the suspension. Here we are talking about true solutions in which the size of particles are very small. Now next question is, why is crystallization technique better than evaporation? Write any two physical properties of each of metals and non-metals and name the technique used to separate cream from milk. First of all, crystallization and evaporation. As you all know, crystallization is a technique in which we get purest form of a substance in the form of crystals. And in evaporation, the liquid substance evaporates in the form of water vapors or in the form of vapors in the air. So in both the methods, the vaporization process takes place. But the difference between these two techniques are, in evaporation, when this process takes place, it will leave behind some impurities also. But if we are talking about crystallization, we'll only get purest form of the substance in the form of crystals. That's the reason after evaporation we'll follow crystallization technique if we want crystals of sodium chloride or NaCl from seawater. So first from seawater we'll do the process of this evaporation. We'll collect seawater in a shallow pits. Evaporation process takes place and then after that it goes to the crystallization process. So that's why we'll get that's the reason why we are using crystallization technique, because if we are using this method, we'll get the purest form of the substance. Now, how will you present your answer? Both these techniques are used to separate solid substances from their solution. As I told you, like seawater or copper sulfate, CuSO4. So when it is mixed with water, if we want pure crystals of copper sulfate, which is blue in color, we'll use this crystallization technique. Now, but crystallization is considered better because during evaporation, certain solids may decompose, or some of them like sugar get charred when the solution is evaporated. It means it is left behind, but completely to dryness. As a result of crystallization, even the shapes of crystals do not change. When evaporation takes place, so there is a change in the shape of those substances which are left behind. For example, if you take a solution of sugar and water and boil it, then evaporation takes place. So whatever sugar is left behind, so its shape, it's totally changed. But if we use crystallization technique, in this technique or in this method, there is no change in the shape of the crystals. We'll get the purest form. Now, next question is, write any two physical properties of each of metals and non-metals. As we know that metals are entirely different from those of non-metals, but still there are some exception in both, whether they are metals or non-metals. And the question is, you have to write two physical properties. So in this question, you can write any two physical properties of metals and non-metals of your choice. So here I've taken metals have shiny surface, which we call luster. Metals are malleable, means we can convert them into sheets. If you remember, I've given an example to you, aluminium sheets, which we are using as a foil in our kitchen. So metals are malleable and they are ductile. It means we can easily convert them into wires. So metals are malleable and ductile. And if we are talking about non-metals, non-metals are poor conductor of electricity due to the absence of free electrons in them, and they are generally soft, except one non-metal is there, which is the hardest substance known. Name that non-metal. What is that non-metal called? Yes, that is diamond. So diamond is the exception. So in this question, they are not asking difference. They are asking any two physical properties. So you can write any two physical properties of metals and non-metals. Now next is, name the technique used to separate cream from milk. Now, which technique we are using? If you remember, there is a technique, there is a method which we use for separation of cream from milk, and that is centrifugation. Centrifugation we use for separating drugs from blood also. So this method we use for the separation of cream from milk. This centrifugation technique we use in those substances in which the solute are suspended particles, are retained as suspended particles in a liquid, and with the help of a centrifugal machine. So it has axes which churn that mixture and separate the suspended particles, lighter particles that comes at the bottom, and the heavier will settle down. So due to this technique, this centrifugation technique, we can easily separate cream from milk. Then next is, Sam tested the solubility of 4 salts X, Y, Z and T at different temperatures and collected the following data. Solubility refers to the amount in grams dissolved in 100 gram of water to give a saturated solution. And this is the data which is given here. This data is here. Now you need to answer these following questions. Which salt has the highest and lowest solubility at 323 Kelvin? And second is, a student prepared a saturated solution of X at 323 Kelvin and then added 25 gram of water to it. What mass of X must be added to again make the solution saturated? So first understand question. Sam tested the solubility of 4 salts. So they are different type of salts, X, Y, Z and T. As I told you earlier also, like different substances have different rate of solubility. So here Sam has taken 4 salts and their solubility is different at different temperatures, which is already mentioned in this data. What is solubility? Amount in grams dissolved in 100 gram of water to give a saturated solution. So whatever amount of solute we are adding in 100 gram of water to make it saturated solution is known as its solubility. Now X, Y, Z and T. These are 4 salts and different temperatures are given: 290 Kelvin, 313 Kelvin, 323 Kelvin, 343 Kelvin and 353 Kelvin. So these are the different range of temperature and their solubilities at different temperatures are like this. If we are talking about salt X, at 290 Kelvin, its solubility is 22, 313, at 313 Kelvin, its solubility is 34 and At 323 Kelvin, its solubility is 40, and at 343 Kelvin, its solubility is 93, and at 353 Kelvin, its solubility is 109. So now you can see this X salt has different range of solubility at different temperatures. Similarly, if we are talking about Y salt, its solubility is also different at different temperatures. Like at 290, it is 43, 300, it is 43, and 323, it is 46, 343, it's 50, or 353, it's 50. We can take it as 42. Now, if you are talking about salt Z, it also has different range of solubility at different temperatures. Like if 290, 27, 313, 30, at 323 Kelvin, 34, at 343 it has 37, and at 353 it has 40. Now if you are talking about last salt, which is tea salt, at 290 it has 25, at 313 it is 38, and 323 it is 42, 343 it is 54, and 353 it is 64. So this is the data which is already provided in the question. Now we have to answer question number 1. Which salt has highest and lowest solubility at 323? So look at 323 Kelvin. Here it is. And this is the range of temperature, range of solubility at 323. X has 40, Y has 46, Z has 34, and T has 42. Now, so it means highest is Y and lowest is Z. So we can say that at 323 Kelvin, salt Y has highest solubility in water, while Z has lowest solubility in water. As simple as that. Now, question number 2. A student prepared a saturated solution of X at 323 Kelvin. So again, at 323 Kelvin, so a student prepared a solution of X and then added 25 gram of water to it. Now, according to the definition of saturated solution, 100 gram of water at 323 Kelvin contain how much of salt? Which is 40, because we are talking about X salt. And the solubility of X at 323 is 40. So, we have written 40 gram here. Now, if we are adding, because this student is adding 25 gram of water to it. So, 100 plus 25 becomes 125. Now, it becomes 125 gram of water again at 323 Kelvin. Because the question is, because when he added 25 gram of water into it, now it becomes 125. Now, what mass of X to be added? So, we need to find out that mass of X. So, what is the formula? It is mass of the solute, which is 40 gram, upon 100 gram, which is already mentioned, 100 gram of water according to the definition, and multiply by 125, because now it is total 100 plus 25 is 125. And after solving it like this, 40 upon 100 into 125, so we'll get this answer. 100 upon 2, it is 50 grams. So this is how we get this answer. So now question is mass of salt to be added to make the solution. Earlier it was 40 and now in 125 it is 50. But we need to find out it 100 gram only. So we'll subtract these two with each other. 50 minus 40 and we'll get 10 gram. It means 10 gram of this X salt can be added to make the solution saturated. So I hope this question is clear to you. And next is the solubility of which salt is least affected by increase in temperature. So as we can see here, I have written 42 here. Now look at these salts. Just see the difference in the solubility range. And if you look at the difference in the solubility at different temperatures, we can see that X is the only salt in which there is a very less difference in their solubilities at different temperature. So answer is salt Y is least affected because the range in the difference in the solubility is quite very less. Now next question is, what mass of tea would be required to make saturated solution in 200 gram of water at 290 Kelvin? Now here we need to find out mass of tea. So at 290 Kelvin, this question is similar to the previous one which I have already discussed with you. At 290 Kelvin, this is 290 Kelvin and this is the mass of tea required to make saturated solution in 200 gram of water. So it is mentioned 25 gram upon 100 according to the definition. Solubility, amount of solute to be added in 100 gram of solution to make it saturated solution. So this is 25 upon 100 multiplied by 200 gram which is already mentioned. Now and we'll get 50 gram is the answer. So question number 2 and 4, they are similar ones. Now I hope till here this question is clear to you. Now next is, how will you separate a mixture containing acetone and methyl alcohol? Difference in their boiling point is less than 25 Kelvin, which are miscible with each other. Again, one more question, I have already done this one. This question number 2, in which the difference in the boiling point is below 22 degrees Celsius. And here, it is mentioned the boiling point is less than 25 Kelvin. If the question comes more than 25, then the answer is by simple distillation. But here it is clearly mentioned they have given they have given a mixture which is a mixture of acetone and methyl alcohol, and the difference in their boiling point is less than 25 Kelvin. So if the difference is below 25 Kelvin, so we'll use fractional distillation. And if it is more than 25 Kelvin, so we'll use simple distillation. Now next is, what type of mixtures can be separated by technique known as crystallization? As I told you, crystallization is a method in which when we heat a substance, then the liquid substance evaporates or convert into vaporous form because we are not providing direct heat, and we'll get the purest form of the salt in the form of crystals. Now here, these solid mixtures in which one component or impurity is less soluble in a particular solvent as compared to the other. An example of such kind is samples of copper sulfate, potassium nitrate, potash alum. They can be purified by this method. So if you remember this copper sulfate, which is blue in color, I have already explained. This crystallization is a china dish in which I have taken copper sulfate. Here water is present in this beaker and we are providing heat to it. So as you can see, we are not providing direct heat. So we are providing heat to water, then this heat reaches to copper sulfate and the water which is present in it, it evaporates. in the form of vapors and will get crystals of copper sulfate, which are blue in color. So I hope this question is clear to everyone. Now children, these are very important questions and these are frequently asked questions. They can be asked in exam in any form. Now question number 9. Question is, sodium chloride contains two elements. If we are talking about sodium chloride, that is NaCl, it contains sodium and chlorine, but it is still a pure substance. Give reason. So if we are talking about sodium chloride, sodium and chlorine, they both are present in sodium chloride. So if you are talking about pure substance are those in which one type of substance or elements are present. But here two different elements are present. It's a compound. But why it is a pure substance? Any idea? Yes, the answer is because sodium and chlorine which are present in it, they cannot be separated by any physical method. So that's why we call it a pure substance. We cannot separate by sieving, we cannot separate by filtration. So we cannot separate by any physical method or magnetic separation. We cannot use those methods. So that's why we call it a pure substance. Because if we need to separate sodium and chlorine, we use electricity. By electrolytic decomposition, we can separate sodium and chlorine, which are present in sodium chloride. So that's why we do not call it a pure substance. Now next question is, calculate the mass of potassium sulfate required to prepare its 10%. The mass percentage is given. Solution in 100 gram of water. So potassium sulfate, it's a solute. And it is dissolved in 100 gram of water, which is a solvent. So we use this formula, mass percentage is equal to mass of solute upon mass of solute plus mass of water multiplied by 100. These formulas I have already discussed in previous classes. So kindly learn all the formulas. Then only you will be able to solve these numericals which are based on it. Now mass percentage is given, it is 10, and mass of solute, we don't know the mass, so we'll write X. Mass of solute is X plus mass of water is given, which is 100 gram. So we need to find out mass of solute. So we have taken it, assume it X. Or we can write like this, 1 is equal to X upon X plus 100 into 10 after solving this. Or if we'll take this here, we can write like this, X plus 100 is equal to 10X. So we'll multiply this 10 with this X, 10X. Or 100 is equal to 10X minus X, so we'll get 9X. So I have written 9X here is equal to 100, or then after this we'll write X is equal to 100 upon 9. So after solving this we'll get 9.1 gram. So 9.1 gram of solute is required to prepare its 10% solution is in 100 gram of water. So I hope this question is clear to you. So numericals can come on mass percentage, volume percentage, or you need to find out the mass of solute, mass of solution. So a question can come in any ways. The next numerical is, what volumes of ethyl alcohol and water must be mixed together to prepare 250 ml of 60% volume by volume solution of alcohol in water. So here we'll use volume percentage formula. So this formula also I have already discussed in previous class. So volume percentage is volume upon volume of alcohol and volume of solution. So here ethyl alcohol is a solute and water is a solvent here. Now volume percentage is already mentioned, which is 60, and volume of alcohol we need to find out. So we'll assume it X, and volume of solution is given, which is 250. Multiply by 100. So again we'll take X here, or we'll 60 into 250, because when it goes here, so it's reciprocal, then 250 multiply upon 100. Or you can write like this also, upon 100 into X. And I have written like this. So after solving it, we'll get 150 ml is the answer. And we need to find out how much volume of water we need. So whatever is given in the question, that is 250, just subtract this 150 from it and we'll get 100 ml. So this is how we'll get the volume of water. Volume of solute we have find out, which is 150, and volume of water also we have already find out. Now next question is, all mixtures are homogeneous. Is this statement correct? Justify your answer. First of all, we need to understand what is homogeneous mixture. If you remember, homogeneous mixtures are those mixtures in which we cannot see the boundaries of the components present in a solution. So all mixtures are homogeneous? No. There are certain mixtures in which we can see the boundaries. For example, oil and water. If we mix oil with water, we can easily see the boundaries of oil and water. So it is not a homogeneous mixture. It is a heterogeneous mixture. And if we take sand and water, it is again a mixture. But again, it is not a homogeneous mixture. So no, this statement is wrong. Petrol and water, kerosene and water. So if you take these examples, we can say that this is not a homogeneous mixture. So this statement is wrong. Mixtures can be homogeneous only if constituents present in them, the components or the substances which are present in them, are uniformly mixed and there is no boundary of separation of these separation of these constituents. It means we cannot see their boundaries. We cannot distinguish. And a mixture is said to be heterogeneous if we can see their boundaries. As I told you, example is oil and water. If you take oil and water, mix them together, you can easily see the layer of oil deposit on the water. It can easily float. So that's an example of heterogeneous. Then another examples of the sand and common salt is also heterogeneous mixture. You can easily see when you take a mixture of sand and common salt, you can easily see the boundaries. You can easily distinguish sand and common salt. Common salt is that salt which we are using in our daily life. But they are present in same phase. They both here, same phase means solid phase. They both are solid. Sand is solid, salt is also solid. But still we can differentiate between their boundaries. And that's why we call them heterogeneous. So as you can see in one question, how many type of questions can come? A question can be come in this way also. A mixture of sand and common salt is a heterogeneous mixture. Comment on it. So you need to explain it. Although they belongs to the same phase, still we can see their boundaries. So that's why it is a heterogeneous mixture. So question can come in any ways. A question can come differentiate between homogeneous mixture and heterogeneous mixture. So in that you have to write homogeneous mixtures are those in which we can see the boundaries of the components of a solution, and in we cannot see the boundaries in a homogeneous mixture. While in heterogeneous mixtures, we can see the boundaries of components present in a mixture. So these questions can come in exam. Now next is, how can a saturated solution be made unsaturated? Again a repeated question, but this question can ask in different ways. So how can we make a saturated solution? There are two conditions as we have discussed. Either by heating, if we heat the solution, it becomes unsaturated one, or by adding more solvent into it. It means if you are talking about temperature, so temperature is directly proportional to the solubility. If we increase the temperature, the rate of solubility also increases. They both are directly proportional to each other. Okay, one more thing, effect of pressure. Question can come on the effect of pressure on solubility. It is inversely proportional. In case of gases and liquids. For example, if we may prepare carbonated drinks like cold drinks, so when we increase pressure, the rate of solubility also increases. So in case of gases and liquids, pressure is directly proportional to solubility. So when we are preparing carbonated drinks, if we increase pressure, rate of solubility increases, the rate of carbon dioxide gas is more. But when we open the lid of that bottle, that carbonated drink, we are reducing the pressure. The rate of carbon dioxide gas is also decreasing. So in case of gases and liquids, pressure is directly proportional to solubility. But in case of solids, it is inversely proportional. Now next is differentiate between compound and mixture. How compounds are different from mixtures? Compounds are those substances in which two or more elements are present in a fixed ratio. For example, H2O. Here hydrogen and oxygen are present together and then they form water. So the composition of elements, if they are present in compound, they are present in a fixed ratio. But if we are talking about mixture, it is not fixed. Like we take an example of sand and water. So we can take any amount of sand to dissolve into water. So that composition is not fixed at all. In the second head, the properties of a compound are different from those of its elements. Like if we take an example of water, it is a combination of hydrogen and oxygen. So these two have different properties. And when it becomes water, property of water is entirely different from those of hydrogen and oxygen. We use water to extinguish fire. It is a combustion of fire. So these properties are entirely different. Another example we can take NaCl. So it is a combination of Na and Cl. The properties of Na, sodium and chlorine are entirely different from those of salt. It means the properties of the components which are present in a compound, they lose their property. The components lose their property once they form any new substance. Here you can see hydrogen and oxygen completely lose their property when it becomes water. Similarly, in case of sodium and chlorine also, when it becomes salt, it loses its property. And the constituents which are present in compound, they can be separated only by chemical methods. We cannot separate them by physical means. Any physical method we cannot use for the separation of components present in a compound. Then a compound is always homogeneous in nature. And if we are talking about mixture, it shows the properties of all of its constituent elements. Like if we make a mixture of salt and water, so it retains the property of salt and water. Its constituents can be separated by physical methods. Like by filtration, we can separate if we have a mixture of sand and water. So by physical methods, we can separate. Our mixtures can be homogeneous or heterogeneous. So these are the differences between them. Now, what is the effect of change of temperature on the solubility of a salt? Thus, now I have discussed similar question with you. Solubility of salt is directly proportional to the temperature. As I told you, temperature is directly proportional to solubility in case of solids. So if we increase temperature, the rate of solubility also increases. But in case of liquids, it is opposite. Solubility is inversely proportional to temperature. When we heat liquid, so maximum amount of the oxygen gas escapes out. The solubility of oxygen is reduced when we increase the temperature. So in case of liquids and gases, solubility is inversely proportional to temperature, but in case of solid, they both are directly proportional to each other. So I hope these questions are clear to you. And in next class, I'll discuss, I'll start with a new chapter and have to thoroughly go through each and every question. And another question is, write a method to separate a mixture of salt and ammonium chloride. So this method, with the help of sublimation, you can easily separate salt from the ammonium chloride. So these kind of questions I have already discussed with you. And this is an activity in which you need to explain entire steps one by